Welcome to the workshop. Today we will assemble the Piranha CNC that has been developed here. Behind the cameras we have Alex and Todor that will help me. We have a multi-camera setup. We hope it will work and we hope you will have a great time building the Piranha CNC. We have put the spoilboard on today just for show. It's not a part of the kit. You can make it yourself easily and we will share the files how to make it. So let's get going. In preparation for the assembly, we have already pre-threaded all the ends of the C-beams. So we have threaded 4 holes in each end of all the C-beams. And we have also pre-threaded 1 hole here and 1 hole here in one of the two 20 by 40 beams in order to have that prepared. We have also been working on the motors, so we have cut off the wire and added an extension switch connector here, so we have all that done up front. The first step we will be doing is to mount the rails to the C-beam on the Y-axis, so this one here. So the first thing we will be doing is use some M4 14 in each of these holes. We'll add them here. And then we will add a T-nut on the back side, like that. So now, having done all the screws here, we'll slide it on. Then the next we will position how to position this one up and down, and for that we have made these small brackets here that you mount with some drop-in T-nuts on the top here. Have to be parallel to the track. Like that. One each end. They have a distance that is 2.5 millimeter, and they will position the rail 2.5 millimeter below the surface of the C-beam here. So I'll simply just put it up against this one and secure that the ends are aligned, and then I will tighten up the front here and the end. And then I want to slide this one just a bit to the middle, tighten it up again, and then tighten a few here, and then this is so stiff that now we can essentially tighten up the whole set here. Now for the spoilboard, this is the top. It will be turning. We will be turning this way, and then we will mount underneath 3 of these, and we will do it so that it faces out at number 5, 9 and 14, and I will simply slide them on at the end here, and number 9 is 3, it's here, I will mount it here. That should be perpendicular to the axis here. Same goes with the next one. Then number 5 is here. And this is not something that needs to be super precise. These are just there as support for your MDF spoilboard. And the last one, it will go to screw number 13 or 5 in from the end, if you prefer that way of saying it. 5 in around here. So then they should be somewhat equally distributed over the surface of the spoilboard. So that was the end of this one. It's gonna look like this. And I'll take these off because I need them for the other one. But this will be my right Y-beam. And then we have cheated a bit because we've already mounted all these. So, and then we are ready to do the positioning. We will mount the alignment tool here on each side. And as with the other one, you can rock it around. So we move it up, we align the end, and we tighten the end here. The same in the other end. And then we move one down the middle. And secure one of them. And then we secure the rest. And the first one goes to screw number 9. In the middle, right here. Second one goes to hole number 5, or screw number 5 here. And then the one at the end. Screw number 5 or 13 from the other end. It's here. Then I'm sitting with the left beam on Y. It's going to go over here, and I want to mount the limit switch. I have it here with connector and everything. It's going to be put here in this groove here, so the C part of it. It's going to have a little room here, like going into the plate, so we will probably do something like this. So we have it here, and you can slide it forward and backwards. So that's for that one. And then we will mount these 3 to the beams. I'll turn it around like this, and this, and then I will slide in, and I will take those 3 that have no threading in it. So this and this that I had threaded one hole, I will leave, and I'll take these ones and stick them in. 1, 2, and 3. And then of course there's a little alignment needed to be done here. Like that. I'll just loosely tighten it over here, just to keep it together. And I will have to turn the whole thing around in a bit, but for now I will keep it here. We're getting there. When we get the X gantry on, we will have to adjust on some of these in order to secure that it's actually the ex-gantry distance that determines the width here rather than what I just put together here. So again, you will have to come back to these at some point in time. So, you can turn it around, fine now. I'll move it like this, because this is how I intend it to be. I have the switch over here. This is my left front and my right front, and this is the back. Okay, so next we will be mounting the blocks onto the linear rail, and you should position it so that the oiling tip is facing away from each other. So one I will be facing this way and the other I will face this way. And you have this little plastic thing insert here, and you have to secure that you, as you push it on, you take the insert out, but not more than that, because you run the risk that the balls in the bearing will fall out. So this is the way you do it, and one facing this way, and then this one I will be putting on here, like that. Same story on the other side. Having mounted the 4 blocks on the rail, we have them here. The next thing we will be doing is preparing the front and the back. And again, I have the threaded hole down here. I want them over to my left side and facing down. So I will be mounting, sliding these ones on. It's a little tricky. You have to make them come on in pairs. And here we have M510 screws into the T-nuts. Then last part for the front here is to get the switch mounted. It goes in with some M3 button head screws and a little lock nut. So just align it with the side of the gantry plate or the corner plate here, and tighten up the... In this step we will be working on the X carriage. We have the plates here, and they will come on like this. We have the X rail out here and the 2 linear rails that will be put on it, and we have the measuring tool we will be using for adjusting it. But the first part we'll be doing is to mount the 4 Acme blocks. 2 blocks on this one and 2 blocks on that one. We will be using our experimental spacers here. We will produce these in aluminum or pop for the kit, but for now we still have these ones that we made in plywood. And they will come onto these holes here, the oval holes here, with some M550 millimeter screws. So you put those 4 in here, and you will notice that they are in oval holes, and the holes are made oval in order for you to be able to move the Acme nut blunt a little forward and backwards in order to remove the backlash. I have M5 lock nut. I'll just align them by eye, and then later we will position them as they fit. Do the same for the other side. Like that. Okay, next is to position them and mount them here. And I'm using M412 here. It's going to be 8 in total. Right now I'm just trying to get the alignment here. Out the way. Same story here on the other side. So we move those out of the way, and then we will start to mount the rails on the C-beam. And again we have the front here, and then the rails will go on here. And this time we have added all of them from the beginning, so hopefully I can slide it on fairly easily. As mentioned earlier, this is M414 with a M14 nut. With the first one here in place, I will put on the alignment tool, as we did before. Put it down, up against it, tighten the first and the last. And then move it up a bit to the middle. And tighten it up here again. Like that. And out with the alignment tool. Same story for the next one. We slide it on. And then out with the alignment tools, we will save them for our Z-axis. Next, you will put in 2 T-nuts, one in each track here. They will be used for the drag chain at a later stage. And then we have these small cast corners that we will add to the both ends, so that they don't slide out. I'll just carefully add in here a little tension. And they have M5-8 and a T-nut. So that was one on the top. So that's it. Then next step, before we mount this up here in between the 2 Y gantry plates, we need to slide on the X blocks, and I have them here. And the same story, you have to get this turning right and the other one going left. Okay, with the 4 blocks on the guides, we will continue arranging the X gantry here, and we will use M5-15 going into the rail. For these we need M5-15 and a regular M5 nut on the other side. We attach it. this will add a lot of strength to your axles. Next one. Alright, same story on the other side. The M550 into the ends. Okay, having finished this up, we just want to be sure that we have everything working as it should. You should have your 20 by 40 more or less flush with the ends here at both ends, and you should be able to slide the carriage forward and backwards without any issues at all. If there's any issues, you of course need to adjust the angle of the tensioning up in front or back if you find any issues. The same goes with this one. They're still a little loose. I haven't tightened them up. You have to secure that they are fully aligned with the gantry here, and then you tighten those up. And the last thing you also should consider is the squaring of the system. Is the distance from this corner to this corner the same as this? Otherwise you may need to adjust it a slightly bit and then tighten it up. So all those things should be in place by now. And then we will continue working on the XC gantry. We'll take this out of the way and we'll work on that in a minute. Okay, so now we need to assemble the XZ gantry, and we will start with the rails to put them on the C-beam. Then we will add the blocks. Then we will remember to add some T-nuts for the spindle mount, so otherwise we cannot come to them. And then we will lock it up with the end plates. And then we will continue with the XZ plate and the Acme nuts. So let's get started. So start sliding the rail in here, as with all the others. It's a little easier, only 4 screws, like that, and the other one. Like that, and we will do the alignment with the alignment tool. And this time we don't need to move anything, just secure that the ends are flush. There. And this was the last time we will be using these. Until next time you need to disassemble. Then we add the blocks. And again I will let the oiling point turn each way. Like that. Everything is fine. Turn it upside down and add 2 T-nuts in each track. And these will be used for the spindle mount if you're using the spindle mount that we have designed. On it. Then we have the end mount, M515, and we will add that here. And please note that the heavy plate is the bottom side, and the little less heavy one that has the hole for the rotor will become the top side. And another 4 M515. So this is out of the way, and we will continue with mounting the acme nuts. And the same story like before. We have the plywood experimental ones that will be replaced. We take M550 and put it through. Add the plywood spacer and then the acme nut. And again we have oval holes here that will allow us to adjust away the backlash. And then the anti-backlash nut goes on the other side, also with M550, and a spacer just going the other way. And the anti-backlash nut, you will turn it this way, so the adjustment screw is facing up against this part here. So at this point it is a good idea just to adjust your anti-backlash knot. So thread the Acme through into the anti-backlash knot all the way through, and then you can feel that it's very, very loose, like right now. Turn it extremely easy. I take the Allen key and I start to attach, add a little pressure, and already around here I can feel that now I'm getting tension, but not much tension, but some tension, which is then enough to having removed that backlash that I want to remove. So I will then have to take a key here, it's a number 8 millimeter, and tighten up the screw or the knot here in order to keep the set screw in place. And then I'll just try again. Yeah, it feels really good. It goes easily, but there is, I can feel that there is a slight tension in it. And it is good and fixed. So we can take that out again. And we will then add this bracket here that will be part of our system for cable management. It's M5 15 and 2 ordinary M5 nuts we're adding here. And I'll just tighten it up, don't over tighten it, it is plastic after all. Now that I have this one, I might as well use it. Okay, then we are ready for the okay. So next is to connect the C axis with the XC plate. And again, this is down and this is up. So we will push these a little apart so we can get this down and then push them in. And you simply push them in so that they fit with your holes. And then you take some M4 12. And the first, you simply just put in one and then try to get it threaded. That went fine. You thread one hole in all of the blocks. And having done that, then it's easy peasy to add the rest of the screws. So if everything is well aligned and so on, it should move freely forward and backward, and you can see it's doing it, running really nicely. And I'll tighten up using the screwdriver. I only use the machine just to get it down. I'll finish it off with the screwdriver here. Put some tension to them. So, next we will add the Acme rod. We have cut it off with like 10 millimeters or so from what you have been supplied with. It's more like 28 centimeter long rather than the 29 that is supplied. What we will do is we'll stick it through, and then we will, for the this is the bottom end where the big plate is, we will add a bearing. a shim and a lock collar, and then we will thread it through the acme knot, and then on the other side we will then add a lock collar, a shim and a flange bearing that fits in the hole in the top plate. So first the bearing. First the bearing, then the little shim, and I'll put the smooth part up against the bearing, and the less smooth one up against the lock collar. Just check that the set screw is sufficiently out. Then I'll go down and see if I can find the acme. I found it. Threading it through. And then this time we start with the lock collar. And then the shim, the smooth side facing to the plate side. And then the flange bearing, and of course you have to have the flange facing the rod. Then we push it up, and you want this one to be more or less flush with the bottom here. And then we need to fish down, or maybe we can see if we can knock it down. Fish it down like that. The lock collar here and the bearing. I put it in like that and tighten the lock collar here. Like that, and then we have the same story up here. I want to fish everything up and put it against here. And I will put a little pressure on the rod with my thumb here, and then tighten up the lock collar. Like that. Doing this may give you some marks on the rod, so if you disassemble and assemble, maybe you will find that you can have some issues. And then let's try it and see how it moves. And it should be like it is. You can move it with your fingers. Everything is moving nice and smoothly, and we are ready to start the final assembly with the main gantry. Okay, so next step is that we will be mounting the XZ carriage onto the X beam, and you can see we have separated the blocks here so this one can fit in between. So I'll actually stick it in here, and then I'll be moving these one in from the one side and the others in from the other side. And now it's actually to some extent resting on it. And then I will just fix it with one screw in each of the two top blocks. Like that. And then I will fix the lower block with one screw. And then I will simply fill up with the rest. And then tighten it up by hand. So if everything has worked, it should be easy to move it up and down and left and right. Which looks great. So next step will be to add the Acme screws, lead screws, to both the X and the two Y axes. Okay, we have turned the setup 90 degrees and we are ready to add the lead screw to the X axis. And what I will be doing is I'll simply insert it here at the bearing end, and then I will be going through the first Acme knot, start to thread it there. And it's fairly easy to thread now. I hope I will hit the second Acme knot soon. Came there. And it becomes a little more difficult for me to turn. I will then just check if I'm all the way through it. I'm not really all the way through it yet, like that. I will loosen up these ones slightly. Now they can align the distance and the angle. And that made it a lot easier for me to turn it. Probably fine. And I will then try to remove the backlash. I will tighten one of the two Acme knots here. It's still going fine. And then I will essentially push my Acme rod with my left hand, and then I will tighten the other one end up here, and probably this will add a little tension to the knot when I start to turn it now. I have some tension on it now. So now we have the Acme rod in place and the two knot blocks positioned, so we have no backlash, and it is turning, but it is definitely a little harder. I need like some fingers to turn it. Then we will add the bearings, and I will start here on the side which is not the side where the motor will be, so this is the opposite side of the motor, and I will add a flange bearing. Then I will add a thrust bearing, a little stack of 3 items, and then the tensioning knot, I will add that one. And I will only add the tensioning knot enough so that it's kind of flush with the surface. And it's not going to be tightened right now, but just add it here so I can go to the motor side and add also the flange bearing. And then the thrust bearing. And then finish off with the lock collar. Finish off with the coupler for the motor. I'll add that one here and tighten it. The coupler will have the same function in this setup as the lock collars had for the Z-axis. It will hold it. And then the last thing we'll be doing is to tighten up this tensioning knot and then secure that we remove any wobble from the lead screw. Okay, so now we're ready for the Y lead screws, and it's very much the same story as we did with the X. We'll stick them in at the end, we'll thread them into the first of the two acne blocks, and then I can feel now I get tension, so I simply need to go and loosen up the second one a bit, and remember they are moving in a oval hole, so now I can easily put it in. Now give it good weight like this, and then I will tighten it up, the one. And when I tighten it up, I would expect I get some more tension on my rod, which I did, but I can still turn it, which is a good indication is that I have removed my backlash. Then we come to the bearings. I'll add the flange bearing, the thrust bearing, and then the tensioning knot. And I will just add the tensioning knot so that it is flush with the end. Something like this. Tighten it up just so it doesn't go off. And I'll move the whole thing down here so I get my stack in place like this. And I'll move to the other end, add the flange bearing, the thrust bearing. And you can see this little part here is what sticks out, is where we will be adding our coupler for the motor. I'll put it in here. I'll secure that I have everything up here. I have it. Tightening it up. So there's also a set screw you need to tighten up like that. Don't overdo it. Then to finish up this side, I'll just loosen again my set screw here, and I will take the wrench here and I will add some tension to the knot here. And again, you should feel that it is good and tight, so it will not be wobbling. And then we'll do the last part here. Same story. Add the lead screw until it meets the first, through the first one and meets the second one, and I feel tension. Then I will loose it up a little bit. And then now I can turn it again easily. So it's now through the second one. And since it's now fixed on the other side, I have to roll it through all the way. Okay, we made it. I will now tighten this one up. Probably we have the right alignment of these two now. And as soon as I do that, it becomes more difficult to turn. But you should still be able to turn it by hand, otherwise you have to continue readjusting so they are straight and everything. So I think this is fine now. I can turn it by hand. Our flange bearing, our thrust bearing, and our tensioning nut. And again, only mounting it until it gets flush. And now I cannot pull it, I have to turn it toward me. So, here. So with my right hand I'm actually holding the X gantry because it can still move around, so to keep it out here. I add the flange bearing, the stack of the thrust bearing, and then I'm finishing off with the lock, the coupler here. I have the cap head screw, and then the set screw, like that, and then I will tighten up the if you have somebody holding on the other end, it is a benefit. I'm using quite a bit of force, you can see my fingers, to hold it here. But the result has to be that it is not too flexible in that end. Yeah, so now we have this, and we are now ready to add the motors. Yeah, so the next step is to add the motors to the different gantries, and we'll start with the C-axis. We have added the coupler to the motor, and important, you have to secure that the flat side of the motor is facing where the set screw is, and then tighten that one up, and also the cap head screw on the other side. And then you will be mounting it on some standoffs, wire facing me, and then the standoffs and some M550 screws to hold it to the motor plate here. And then we need to remember to tighten the screws for the lead screw. So when we turn the coupler, the C-axis will actually follow. That was the cap head screw, and then we take the set screw on the other side, like that. Don't overdo it. And then now when motor is turning, the C is going up and down. So now the next one is the X motor, and I have the flat side facing up, the set screw facing up, and the wire facing down. I'll add the motor, and then a spacer, and M550 screw into the threaded hole in the gantry plate. So, then we tighten up the lock with a coupler on the motor side. And also the cap head screw like that. And again, as you see, I can move the thing by fingers, which is a good sign that everything is correctly mounted. Again, set screw up, flat side up at the motor, into the coupler. And then we lock the set screw on the motor and the cap head screw. That, and then we finish up here by tightening the set screw. Like that, and the That's it. So all 4 motors are ready now, and I think the last part we need to do is to finish up with the cable chains. Yeah. So we will now add the drag chains. We have 20 by 40 here. We have cast corners mounted with an M8 screw, and then they will go on here with a spacer. Have a spacer and a screw here, and this is why we had to make the threaded holes here in the 20 by 40 long time ago. Same in the other end. Like that. Then you slide in 2 T-nuts in the track here. And you can mount your drag chain using an M8. A little washer on. And the exact position of this you will have to find out a little later when you start moving the system. Essentially, when the gantry is moving forward, you should have enough here, but you don't really need it to stick out like this. So then you can adjust it down here to fit wherever you want. So for now we just fix it here. And we add a plastic bracket here. And we tighten it up. And attach the drag chain to the plastic bracket by 2 M512 and an ordinary nut. Okay, so we will add the X drag chain here, and you remember we added 2 T-nuts into the track a while ago, and those 2 we will attach the drag chain to using a M510 with a shim on. And then we'll add screws and nut on top here to the plastic bracket. So like that. And then I have the switch for the Z-axis here, and we have mounted it on a piece of acrylic with button head screws and 2 screws going through it, M5 screws, and we'll mount that and it will happen down here on the C-axis. There's 2 holes down here on the lower level here. Simply add this one. And you have to get the holes, or the 2 screws in at the same time. So put a little in the second one and the first one, so on and so forth, until you have it fixed to the plate. Tighten it up like that. And then we take the wire, and we want it to be over here into this one. Okay, so we will finish up with a cable shield here to organize the cable. And it is a little tricky. You need to get the wire all the way in order to press it in to the groove, the C-beam, like that. Okay, the last part we will show here is the limit switch on the X rail. We'll pull the wire through the hole, including the tape, and then mount it here with M3 button head and the lock nut on the back side here. So, and then I think we will conclude with this, explaining how the wiring are supposed to be. You will collect all your wires from the this gantry up here, the C gantry, including maybe the spindle, go into this one on the X, coming all the way out here. And if you need something, you can strap it together. It will then combine with the X motor. You will put it into this drag chain here, coming around and out here. And then you can have your control box either here in the back, or you can feed some of the wires through this rail all the way forward if you want it in front. If you want it hanging on the side, you can also take it from here. So that's a little up to you, but good luck with the assembly. I'm here together with Todor and Alex, two interns working on a CNC project. We are working on creating Piranha, a very strong CNC based on the open build system, but enforced and strengthened in several ways. We will show you a few of the details in this video, and later we will also publish all the details on openbuilds.com. Right now we have worked on the prototype, and we started out making every single piece in MDF in order to find out how things would come together. So we made all the corners and set brackets and Y gantry plates. But now we are here at a point where we have made all the plates in aluminum, and we would like to show you some of the details.
For our construction, we would like to show you that we're using a pair of high-profile 50mm rails together with 4 linear blocks, and we're using the same principle of motion on all 3 of our axes. They are accompanied with gantry plates that are cut out of 6mm aluminum sheet to our specifications.
So we have used a lead screw driven drive system, and let me show you some of the details of that. Yeah, so we have the stepper motor here connected to the coupler, and then in order to take the axial force we have a thrust bearing and then a flanged bearing sitting inside the plate here. Then we have the Acme rod going all the way to where it meets a set of Acme blocks, one on each side of the Y plate. In order to make the system fit from the plate into the block, we had to make some spacers. They have to be very precise in dimension, and for now a prototype we have made in plywood. However, the plan is to make them in POM or alternatively aluminum for the final production version. And then at the end, on the outside, we again have a stack with a flanged bearing, a thrust bearing, and then a lock nut that can tighten up the Acme lead screw so wobbling is reduced.
For the controls, we are using the black box from OpenBuilds. The machine has 3 limit switches with the possibility for up to 6. Now I will demonstrate the homing sequence. And as you can see, everything worked as intended.
So the idea now is that we will try to run a Hello World program, and we have made this fantastic tool here with a pencil marker attached to the milling machine. So we will stick it in here, and then we will try to run a Hello World.